This is an AQA GCSE chemistry question. It's from the Trilogy Foundation Paper 2 of 2018, and this is question 6. So the whole question is coming up to begin, so you can pause and have a go for yourself, and then review at the end of the video. So here is 6.1, 6.2, 6.3, 6.4, 6.5 and 6.6, 6.7, and finally 6.8, 11 marks available in total. So let's go back and review. Crude oil is a mixture of hydrocarbons. The hydrocarbons in crude oil are separated into fractions by fractional distillation, and we've got the column shown on the right hand side. Crude oil vapour passes up the column, and then each fraction. And what we're looking for here is they condense. So we've evaporated them, they rise up and they condense at different levels. And it's worth remembering that shorter chains will condense higher up the carbon chain because they've got lower boiling points because they have weaker intermolecular forces. A little bit more additional information there. 6.2, why do the fractions separate? So this is a simpler way of looking at what I've just said. The fractions have got different boiling points. On 6.3, you are being asked to name the alkane. So the first thing to look at is how many carbons there are. 1, 2, 3. And for that, you have got to remember that 3 carbons in a chain will have the prefix prop. It's an alkane. There are no double bonds. So what we have here is propane. On to 6.4, we've got methane, which is an alkane. What is the general formula for alkanes? Again, you need to know this, you need to remember it, but let's try to see it in action. I've also added ethane, propane, and butane. So CH4, C2H6, C3H8, C4H10. When finding the formula that fits that pattern. And what I can see in every single case is if I double the number of C's and then add 2, I end up with the number of H's. That gives us a formula CnH2n plus 2. Moving on to 6.5, we are doing a combustion of alkanes equation. I'm always going to recommend you follow the rule of Cho here, balance the carbons, then the hydrogens, then the oxygens. So I've got 1 carbon on the left and on the right, but I've got 4 hydrogens on the left and 2 on the right, so I need 2 H2O. That now means I've got 4 oxygens on the right, 2 in a CO2, and 2 in 2 H2Os, so I need 2 O2 to balance that one. And what reagent is used to test for alkenes? The correct answer here is bromine, and it will decolorize brown bromine water if an alkene is present. On to 6.7, why are life cycle assessments done? So we've got a lot of information here about life cycle assessments, but we do them to assess the environmental impact of all stages, from the manufacture to the packaging to the waste of going into landfill or recycling, all stages in the life of a product. And finally on 6.8, we have got a levelled response question here. So you can see very similar ideas to many questions, whether it's level 2 or level 1. And we are looking for the indicative content that you can see here. And it's worth pausing to go through to look at how we're using that data. And that takes us to the end of this question.